In this lesson, I'll show you how to set up first-order differential equations. When reading the problem statement, always look for words like slope or rate of change. Each of these can be represented by the first derivative. The question reads, the slope of a curve at each point is 1/10 the product of the ordinate and the square of the abscissa, and the curve passes through the point 2 and 3. Find the equation of the curve. So we're introduced to a couple of words here, ordinate and abscissa. Ordinate is the generic word for the y-coordinate, and abscissa is the generic word for the x-coordinate, or the horizontal axis. We're told that the curve at each point is 1/10 the product of the ordinate. We'll represent slope by dy over dx, and that is 1/10 of the product of the ordinate, so 1/10 of y and the square of x. The curve passes through the point 2 and 3, so we will be finding a particular solution here. But first, let's solve the differential equation generally, and we can do that by separating the x and y terms. For example, I'll first multiply both sides by dx, and that will clear the dx at the bottom. This will give me dy is equal to 1 over 10 yx squared dx. I want to separate the y and the x, so I'll divide both sides by y. And if I divide both sides by y, this y will cancel out and we'll have a y on the left side. Notice now that we have one term on the left side that is exclusively in terms of y, and the term on the right side is exclusively in terms of x. This means that we're ready to find the integral. So I'll find the integral of the left side and the right side. The left side isn't hard. We have the function 1 over y. 1 over y integrates into ln absolute of y. Moving on to the right side, we have to integrate the function x to the power of 2 over 10 with respect to x. So I'll add 1 to the exponent, and we'll divide the expression by its sum. So I have 3 times 10, and we end up with x to the power of 3 over 30 plus c. X to the power of 3 over 30 plus c. Now I can use what they gave me, which is the point 2 and 3, to find out what my c value is. So I have the point 2 and 3. I'll substitute this 2 into here, and this 3 into here. This gives me ln absolute of 3 is equal to 2 to the power of 3 is 8 over 30 plus c. Solve for c. I have ln absolute of 3 minus 8 over 30. I'll use my calculator. Ln of 3. No need for the absolutes. Minus 8 over 30. And this gives me 0.83. 0.83. Therefore, my equation is ln absolute of y is equal to x to the power of 3 over 30 plus 0.83. And there you have it. That is how to set up first-order differential equations. Make sure to watch question 2 for a more challenging example.